Hi everyone, my name is Tan Zimin. Hi, I'm Andrew.
Hi, I'm Darren.
I'm Xiu Jun.
Hello, my name is Lee Huan Hao.
Hello, my name is Lo Bao Liang.
Hello everyone. Today we will be discussing on determinant of matrix. Before that, what do we know about determinant of matrix? The determinant of a matrix is a scalar coordinate value or number calculated using a square matrix. The square matrix could be a 2 by 2, 3 by 3, 4 by 4, or any type such as S, n times n, where the number of columns and rows are equal. So what is determinant is used for actually? Determinant is used to determine whether a matrix has an inverse and let us know if the system or equation has a unique solution. Let's take a look here. If determinant of A is equal to 0, hence there is no inverse. But if determinant of A is not equal to 0, then we can make a conclusion that there is an inverse. Here's an example for 2 by 2. So we use your cross multiple 4 times 2, and then the other side 4 times 2 again, and we get this equation here, 4 times 2 minus 4 times 2, and then we get 0 when we do the subtraction. So hence we will know that there is no inverse because the determinant we get is 0. Now we will discuss on properties of matrix. So there are a few properties that we need to remember. For the first one, if A is a square matrix, then we can say that the determinant of A is equals to the transpose or determinant of A. For example, we can take a look here. A, B, C, D, and then on the right hand side, you can see that the first row AB is interchanged to the first column, and the second row CD is interchanged to the second column. And in this property, we say that the determinant is equal. For the second part, if the matrix of B is obtained by interchanging with any two rows or two columns of the matrix A, then we can say that the determinant of A is equals to negative determinant of B. For example, A, B, and CD is equals to negative CDAB. By switching the first row to the second row and the second row to the third row, and then by adding the negative here, we can say that they have the same value for determinants. For the third one, if any two rows or columns of the matrix are identical, then the determinant of A is equal to 0. For the fourth property, if the matrix of B is obtained by multiplying every element in the row or the column of the matrix A with a scalar k, then we can say that the determinant of B is equals to k determinant A. Coming to the last part of this session, if the matrix B is obtained by multiplying a scalar k, or one row of the matrix A is added to another row of A, then we can say that determinant of B is equal to determinant of A. For example, in this part, A plus KC, B plus KD, and CD is equal to determinant of AB and CD. The last one, if the matrix of A has a 0 row, then the determinant of A is equal to 0. For example, AB 0, 0 is equals to 0 because in the second row we have all 0.
Hi everyone. First and foremost, I'm going to share with you all about the 2 times 2 matrix determinant. The step to get the determinant of 2 times 2 matrix can be really easy. All you need is just memorize and practice the formula of it. As you can see in this slide, we are going to perform cross multiplications in order to get the determinants. But don't forget to add a negative sign for the multiples of A12 and A21. Here's another form of the formula which is in algebra form. Each number of the 2 times 2 matrix has been replaced using algebra A, B, C, and D. The formula to get the determinant of A matrix will be AD minus BC as written. Lastly, as a reminder, don't forget the symbol of determinant is 2 straight line, which is different from brackets of matrix.
Hi everyone, so now I'm going to talk about example for determinants of a matrix 2 multiplies 2. Example 1. To find the determinant of B, we apply the formula we learned before. We use B11 multiply with B22 minus B12 multiply with B21. B11 means the value at the matrix of row number 1 and columns number 1, which is 1. Then B12 means the values at the matrix of row number 1 and columns number 2, which is negative 1. Hence, we get 1 multiplied with 3 minus with negative 1 multiplied with 2. Then we get the answer, which is 5. Besides that, we also can imagine a picture that I think can easily help us to find the determinant of B. By imagining this picture, we can clearly see that we need to start from 1 multiplied with 3, then minus with negative 1 multiplied with 2. Then we also can get the same answer, which is 5. Example 2. Find the determinant of C. By imagining this picture, we can start from x multiply with x minus with 1 multiply with negative 1. Hence, we get the determinant of C, which is x squared plus 1.
Hi, so I will be showing you how we could find the determinant for 3 by 3 matrix. We have to first understand that for 3 columns is assigned with either positive or negative. For the first and third column, it is positive, while the second column is negative. We will take the first element of the first row, which is A, and we'll take out all the elements in row 1 and column 1, leaving E, F, H, I. With the second and third element of the first row together with its assigned positive or negative, and we will get the equation on the right. We could expand the equation into the one at below by using the method with how we find the determinant.
Hi everyone, I'm going to explain how to find the determinant of a 3 by 3 matrix. So, the first step, we choose any row, then we cover up the first column. What we left is 8, 5, 0, 1. So we copy this. Next, we put a minus sign. Now, we cover the second column. What is left is 1, 5, 0, 1. So 7 multiplied by the small determinant of this. Next, we put a plus sign. Now we cover the third column. What is left is 1800. So 3 multiplied by this small determinant. The expression in this small determinant is 8 multiplied by 1 minus 5 multiplied by 0. The same goes to the other two. Then we get 16 minus 7 minus 0, and the answer is 9. Now I'm going to show you that we can get the same answer even we choose a different row. Here is a tips. We prefer the row which has more 0. This makes our calculation easier. Same, we cover the first column. What is left is 7, 3, 8, 5. 0 multiply this small determinant. Then we cover the second column. So minus 0 multiply the second small determinant, which is 2, 3, 1, 5. Next, we cover the third column and plus 1 multiply the third small determinant, 2, 7, 1, 8. Then 0 times anything is 0, minus 0 plus 1 multiplied by 2 times 8 minus 7 times 1, and we get the final answer equals to 9.
Three, two, one.
Thank you for watching this video. Bye bye.